Good morning or good afternoon whenever you're doing this, or good night. Some of you I've seen like to turn things in real late. So hopefully things are going well for you. We are going to do 12.4a today, and that is finding angle measures with all kinds of different lines. We're going to start with talking about a secant, and a secant is a line, not a segment, but a line, keeps going, that intersects a circle at 2 points. So if you look here at the picture that I drew, notice it goes through the circle. It has a point at the circle here and a point at the circle here. So that's what makes it a secant, and the fact that it keeps going. A chord stops, right? A chord would just be from those 2 points. A secant keeps going all the way through. So it's going to be very similar to a chord in that it hits at 2 different places, but it's a line. It keeps going. Okay, so there's 2 theorems that you're going to do with this, theorem 1213 and 1214. The numbers don't matter, so don't worry about that. But here's what they say. Okay, the first one says the measure of an angle formed by 2 lines that intersect inside a circle. Okay, and that's key here. They intersect inside the circle versus this other one, they intersect outside the circle. They are very similar formulas, but very different at the same time. You'll get very different answers if you do them the same way. So here's what I need you to see. When they intersect inside the circle, it's half the sum, okay, so sum means we're adding, right? Half the sum of the measures of the intercepted arcs. So you could have any one of these be a variable. You have an angle here, you have an arc here, and an arc here. And those 3 things have a relationship, and the relationship is this formula. The angle, angle 1, will be half of the sum of the 2 arcs. Okay, those are the intercepted arcs. Think of it this way. Angle 1 and this angle to the right of it are vertical angles. You want those 2 intercepted arcs. So angle 1's intercepted arc is here, and this opposite, this vertical angle's intercepted arc is here. Okay, so there's always going to be that relationship. The angle will equal half of the sum of the 2 arcs. Whereas when they put it outside, now it says the measure of an angle formed by 2 lines that intersect outside a circle is half the difference. Okay, difference means we're subtracting. So my angle, in this case, we'll say angle 1, is half of, and this is always the bigger arc, or the one that's farther away, which will always be the bigger one, minus the smaller one. Okay, so x minus y, or x minus y, or x minus y. So it's the angle equals half of x minus y. Okay? Okay, so we're going to do a few of those and try it out. So here's what I want you to see on this first one. Notice this. For letter A, the point is inside the circle. For letter B, the point where the 2 lines meet is outside the circle. So what you should right away say is, because this is inside, I know I'm adding. Because this is outside, I know I'm subtracting. Okay? And then what you need to think about is, where do all of your pieces fall? So keep in mind, the formula was the angle equals half of arc plus arc. Okay? So in this, your angle is what? Well, your angle is your variable in this one. So x equals half of, and then arc plus arc. And your 2 arcs, it doesn't matter what order you go in. You're just listing the 2 arcs that you have. So 46 plus 90. So you're going to go half of 46 plus 90. Oops, clear out my calculator here. Is 68. So x would come out to 68 degrees. Okay. For the second one, it was outside. So we're doing arc minus arc in parentheses and taking half of that and setting that equal to my angle, right? So it's an angle here, an arc here, and an arc here. Okay, well the angle is actually given to you this time. So you have a 20 for your angle. So 20 equals half. And then it's always the bigger arc minus the smaller arc, which if you think about these angles opening up, it's always going to be the one further away that's bigger. So in this case, it's 95 minus z. Okay, so if we're going to simplify that, we're going to solve. Right now we have 20 equals 1/2 of 95 minus z. Okay, now you could distribute. I wouldn't. A lot of times when people distribute, they make mistakes. What I would do is I would multiply by 2 on the left and by 2 on the right. I said that backwards, right and left. So you would have 40 equals 2 times a half just gets rid of that. That's 1. So 95 minus z, if we take away the 95, I get negative 55 equals negative z. And then really you're just dividing by -1. So z is 55 degrees. And that would be the measure of your arc. All right, example 2. This one says solve for x and assume that lines appear to be tangent are tangent. So basically what we're looking at is, let's say that's tangent and this is tangent. So tangent here, tangent here. What happens is we have, and if you look up here, notice this one doesn't go through the circle, it's tangent in both places. So we're still doing the bigger arc minus the smaller arc, okay? What we don't know is the measure of either of our arcs, but we do know that we have a complete circle here. So with those 2 points, this is x degrees, okay? I need to figure out what would this be then. And maybe you have figured that out already. A lot of people are like, oh, it's got to be 360 or it's got to, come up with a number. You're not going to have a number here. If a circle is 360 and we know x is over here, this is going to just be 360 minus whatever x is. And that's how we're going to use it to solve for x. Because notice we still only have one variable. So we can say the angle equals half of the bigger arc minus the smaller arc, right? So the angle is 40 equals half. Our bigger arc is always the one that's further away from the angle. So 360 minus x is this arc minus the smaller arc, which is x. Excuse me. So if we simplify that, 360 minus x is 360 minus 2x. Okay, now from here, I again would just multiply by 2 on both sides to get that 1/2 out of there. So it's 80 equals 360 minus 2x. And then we solve for x. So if we take away the 360, we get negative 280 equals negative 2x, and then divide by negative 2, and we get a positive 140. So that means our angle, not our angle, sorry, our arc is 140 degrees. So if we wanted to know this one, we would just plug the 140 in here. 360 minus 140, excuse me, would make that 220. So this bigger arc is 220, the smaller arc is 140. Okay. And that covers it for 12.4a for today. Hopefully that makes sense for you. And let me know if you have any questions.